So, as I said, my name is Bertrand. I'm the founder of Wide.io, and I did work in theoretical computer sciences, digital geometry. So digital geometry and cellular automata, these are massive parallel computers in which we do big abstract theoretical about how can we make modelized things that look like we see in the Euclidean world and make them happen in computers that have completely different rules. So it's more mathematical. It doesn't happen in real computers generally. Or we can think it might work in GPUs, more likely to be in 30 or in 50 years' time that at our level of technology. As mentioned by Andrea too, I worked at the GFLI, the Japanese-French Library for Informatics, with the CNRS, and there I created a computer vision framework because after my theoretical computer sciences, I was interested in being a bit more applied, I would say. And that was a very interesting experience. But what's interesting, I would say, in computer vision is we're interested initially by the question. We're interested by a challenge as researcher. We're interested by, okay, how can I analyze image? How can I make meaning of that? How can I, if you're talking about theoretical sciences, how I can make meanings of prime numbers? And we do our research often in our own thinking about these topics, which are well-known topics. But if you have to make a breakthrough there, you have to come with some very original ideas, and this is what we can bring. And we compete with against all the world on these topics that are very attractive. So if we talk about making meaning of images, you know that there is a lot of conferences about images. There's lots of people working on it. There's lots of big companies that have IPs there. And there's a question for us as researchers of how do we remain at the state of the art? How can we compete against Google when Google get immediately access to the best algorithm when they want it? And we need, while on our side, we often have the feeling, okay, I've seen that great paper, I've seen this great breakthrough, but I don't always have access to the algorithms that are behind. I mean, so if I want to compare with this researcher, I may have to re-implement things. I end up losing time because of that. So that was, I would say, one of the frustration that I had when I was a PhD and a postdoc researcher, when I was in research. And that was something I wanted to share with you, because obviously there are the things that potentially we can have in common, and we can help you to understand why I tried to change the things, why I tried to see things differently. I'm not sure I'm completely right, and obviously it's an exchange. It's not going to be a scientific talk today. I mean, I'm building a company which is not about doing research. It's about changing some things. I have some assumptions behind this company. I have some hypotheses on the way I build the things, but I'm not here to present a research experiment. So globally, to talk about our impact, I think there are some numbers that should be mentioned. If we talk about free software, 90% of it end up being unmaintained, which is not really a surprise, because, of course, we all use the open source software that are used are still maintained, but as soon as it's not used, it's not going to be maintained. But it's often the case actually for our research code, because we are actually small communities working on a small topic, and if it's not a massive breakthrough, it's unlikely that we're going to spend a lot of time maintaining that software. If it makes a balance between the number of publications that come from a university and the number of commercial projects that come from a university, it's about 2%. So it means that most of the time we say we make a breakthrough, but it doesn't find any immediate application for anyone. And if we talk about, okay, maybe we think, okay, I may have more impact building a company. Actually, most of the company are bound to fail for one reason or the other. And if we look at inside the code that we produce, before we claim to do research, we end up producing 90% of code that are glue code, interface code, test code about the test loop, code about, so things that are not per se algorithm. And you think, okay, so if I end up recoding the code of the others, if I end up having to recreate the interface, are we really in 2015 in terms of software engineering? Is it really the way we should do things in terms of software engineering? Is there not some things that can be done to improve this? So I said that, and at the same time, I think that researchers are not that alone and that isolated. I think right now I'm in front of a room with you. You're in a team, and there are conferences, and these conferences are about exchange. But at the same time, this model of conferences is Andrea the old. It still requires to move to see the person you want to collaborate with. And of course, there's a question whether these conferences are going to go online and to happen on cloud platforms. And they kind of do. I do think the conferences will still be required, but how many of you are using online tools today to collaborate, and where are they used? I think that's an interesting question. I haven't got the answer. I can give you some partial answer from my perception, and maybe that can be something we can briefly discuss on, is that, in my opinion, all the global social network for researchers have failed. If you look at ResearchGate, they've been trying to launch their product for 15 years. They start to take off a little bit, but still the problem is that people don't understand why they will have to re-upload their articles, to reconnect with someone that they know anyway because they work in the same field. And if even for Mendeley, it's a bit of a duplicate of DBLB, of okay, what exactly, the value isn't clear. What has been successful on the opposite is where people see a value because it contributes to their work. And people work as small teams rather than thinking that everyone's together. And I'm thinking, for example, of Write LaTeX, where people collaborate, the equivalent of Google Docs for LaTeX, or Kaggle, which is about competitions. I've seen this model have apparently a success in the scientific community. However, if you look at how we distribute software, because to come back to what I was discussing about, in 85, the step was about once every month you update your computer. In 95, you have CDs, and computers were more common, so you update your computer every week. In 2005, you started to have good internet connections everywhere, and good Unix distribution tools that allows you to, with Package Manager, to update your system quite regularly. And the question is, of course, what happened in 2015? And my feeling is that it's almost disappearing. We're going to go towards a cloud that's constantly upgraded in terms of software, constantly moving, where software are linked dynamically, continuously built, and sourced from GitHub, built on some servers, and ready to use for the others. And virtually usable on any device everywhere. It's not, I wouldn't say that saying this kind of declaration is really visionary, it's something. But if we think at it, really what it means in terms of how fast software will evolve later on in 10 years or in 20 years, I think it's worth thinking about it. It's worth thinking to where are we going to in terms of direction. I think I finally mentioned already that point, but that's a slide that comes from Willow Garage about how scientists keep reinventing the wheel. And I think it's something I found really true when I actually created PyCVF as a framework for computer vision, is that, well, because we don't have access to code, we have to recode things, we reinvent things, we try to reinvent standard, but the other one don't manage to follow our standard, and we end up reinventing standards all the time. At the same time, it can be asked whether it's not necessary in science to come with to go out of the standards. Because if you have to be creative, to come something with that's new, you have to come out of the standard. But what it means is that often, in the absence of proper coding standards, in the absence of frameworks that guarantee that the code can be accessed by anyone, in the case where we rely on all kinds of dependencies and we don't clarify this, and where we're not sure whether we're going to maintain the code, it's very unlikely that actually this situation is going to repeat. And this is a problem that motivated me with Wide.io. This is typically so basically it's trying to get people to work more together rather than alone on this algorithm, trying to have people to share more about the solutions that they have in place, helping us to access the latest technology, because I think the cloud, programming with the cloud is still complex for many people. There are various technologies, there's no paradigm that's here, and basically it still requires a lot of time, which is part of the 90% of not research actually, and that shouldn't be directly the work of researchers. But that's an opinion, and that's a question. And the final question is, how much is anarchy that exists necessarily in scientific software is an obstacle to being able to reproduce and run scientific software everywhere. So that motivated the creation of Wide.io, which is a hub for algorithm, a place where we discuss and change of algorithm, and it's also a hub with the industry, meaning that if you put an algorithm on Wide.io, platforms that we're creating, we're going to transform it into an API so that anyone can use it, whether it's in research or whether it's in business, and obviously it becomes a service. So it means that the cloud time is paid by the user of the algorithm, and you can decide of the license. It's absolutely orthogonal with the question of open source. The license is who's gonna receive money for it. You can say that you want it to be a free software. In the case of free software, we're going to give a donation to the Free Software Foundation if you don't claim any right on it, because maintaining any software has a cost. So we think that we should defend free software that are on the platform. And the problem that the platform solves is twofold, is the problem of technology transferred for universities. Once you've got the technology, once you get an algorithm, how do you make it accessible to others? And for industries, how do you find good algorithm? How do you connect with people that have ideas? How do you help them to develop the next generation of ideas? So as a researcher, the typical action that the central action that we expect is to share, to see you sharing your algorithm, which will obviously help you to have an impact scientifically and in terms of revenues too, potentially for the university too. And for businesses, of course, is access to technologies that can be bespoke, or that can be latest or optimal according to a problem. With the question of pricing, of course, that matters a lot for our customer. The idea has been recognized as successful. We presented that idea at Wire 2014. We've been selected by the Digital Economy Catapult as one of the best data startup last year, and we had a successful round on Seeders, the seed round, where we raised money from 165 investors to build the first version of the platform. So the company the initial idea started in 2013, but although we've been successful recently at presenting it and explaining it, and there's been some echo inside of the business angel community, it didn't happen at the really beginning of the project. So we built the first version of the project and we ended up being stuck, and now we're about to launch it because we got the funding, and that's the date for the launch is set to the 15th of March 2015. We already have, of course, something, so I'm going to show you some picture. Basically, that's what you see when you log in. You have a description of the platform on the left side, the best algorithms, the latest algorithms that have been uploaded, and the questions that was triggering this algorithm on the right side, and you can know how many people are interested in that scientific topic, and how many times the algorithm have been used, how many algorithms have been contributed. Once you're logged in, you have a dashboard that tell you which are the latest algorithms, which are the questions on which people are discussing, and what are the latest news on the topics that you are interested in, on the algorithms that you're interested in, the teams that you're interested in, basically what is your environment, it's your social network as a researcher around you, and what are the latest news that can interest you around your topic. Of course, I think one of the central page is a page that discusses about the question. I think the questions are always more interesting than the imagine that the questions are always more interesting than the answer in a certain sense, because this is where there is a discussion, where people will come up with, I've got this idea, you've got this idea, I think this is not working because of that, and where we see the history of how we try to solve a problem. For us, a question has two parts. There is a formal way and an informal way. There is the formal way is being described by types, which in this first version are going to be very light in terms of description. And as we evolve and see how our users are working with the platform, we will try to come with more and more and more formal types describing properly all the aspects of the problem. And I think this is a very, very important part of the project. How do you, a type system is a type of information that is information that you provide about your algorithm and that help you to understand and check whether it will work or not in real life. So it's where we should modelize our hypothesis, where we should transfer our hypothesis about what we know so that we can know which algorithm to apply in which situation. In this page, you have a few other sections that are interesting for us and we will discuss. One will be related to fundings, how you can get funding on that question, whether it's by industry or whether it's by grants. So trying to centralize all the knowledge that we know about, okay, if we talk about face analysis, what are the European projects that are going on? What are the papers that have been mentioned? And what are the companies that are interested in funding something in face edge recognition? How much they're looking to fund and in which conditions? And once you selected and of course you have the algorithm, and once you selected an algorithm, you will be able to test it directly online on the platform, submitting an image and getting the result, having some logs about what the algorithm returned as an individual component of a pipeline. To upload an algorithm, there is a procedure that uses a package manager. So I won't do it online in front of you, but basically there is a few steps that are important for you. Obviously, you could say it's simpler to fill a form, but if you fill a form and you just give me a zip, it doesn't mean that you are compliant with all the rules that are important to make a package that's portable and will work well on the cloud. So it's why it's very important actually to have a small tool that helps you to prepare your sources in a way they can run in any environment in the cloud and where we identify the dependencies and so on. So the first thing, of course, is to download that tool that's called the bridge. Sorry, so I think I skipped a few things in terms of order. So the first thing is to download that tool, create your package, be sure that you follow the right rules, so get rid of the user interface, because obviously if you're running on the cloud, there's going to be no user interface. Be sure that actually everything that's related to data types, conversion, if there is a framework running the algorithm for you, shouldn't be taking care of that, because the less conversion there is, the better it is. If there is a data set, it's very good to separate it from the algorithm. Basically, being sure that good habits are there. If you upload an algorithm or a library of algorithm, basically trying to keep the code clean with only the elements that are absolutely required to run it and separate the test from it. Then checking the dependencies depending on the system so that they can be reproduced on the platform, and then describing which are the algorithms that are inside of the package, different formats for that depending on the language that you're using, whether you're using MATLAB, whether you're using shell script, I say shell script, but any binary on Unix, whether you're using Python, depending on we have different bridge for this. And the final thing is defining if there's a license on it and how much costs the algorithm. To go back on this slide, of course, we're not the only one having this idea of a platform where program could be run live and where people could compare algorithm, where there would be a discussion about the current algorithm. So you might have heard about IPOL, which is Image Processing Online, which is a journal, which is really one of the first actually to have done this open platform where it's really oriented towards scientists, it's oriented toward image processing, but it's not really a social network, not really a place where you discuss quickly about what we are going to do in the next version, and it's not also actually meant to be used by anyone in production later on, so it doesn't help you to commercialize your algorithm. There's a clear competitor on the similar idea right now that has been funded in the US that's called Algorithmia, and they haven't released anything yet, so we don't know exactly where they are, but they have a pitch that's quite similar to our. You probably have heard about Kaggle, I mentioned it before, which is a place for data scientists to evaluate algorithm, but they don't publish the algorithm after, so it doesn't help the community really to improve. And also I tend to think that it gamify too much, even if I like gamification, but I think serious topics, if there are serious questions, need to remain a question, a place where science continues to happen. And it's not because you finish the timeline that the discussion is finished. And various others which are a bit different in terms of form. If you want to know what we are doing, because you can say, okay, maybe it's easy to make a platform that run algorithm. It's not that easy. There are plenty of parameters that you need to pay attention to if you want it to be able to scale. If you want an algorithm to once you've got an algorithm that comes from a university, you need to be sure that it is safe, that it's going to be able to run against other algorithms, that nobody is going to see the data that doesn't belong to someone else. So it means that you need to provide on each of your compute nodes some kind of safe container that's going to run the program and have is completely secure in terms of resources that are accessible for your program. We need also to be able to reconfigure each of these containers very quickly, because 1 second we may be running an algorithm, the second we may be running another algorithm that require absolutely a completely different stack. 1 second we may be on Python, the next time we are on MATLAB, and the third time we are on this version of this precise version of OpenCV, and the next version that should be another one. So that's where we have technology, about being able to switch from one configuration to another very quickly. The second part on which we have technology, of course, is enabling the vertical stack, being basically able to connect from people that have equipment in CCTV and that want to use your algorithm. They use some software tools that actually you don't necessarily want to make the integration for as a researcher. Or if you want to make an app on a mobile, you don't necessarily you just want your program to run on a mobile. You don't necessarily want to become a mobile app developer. So that's where we also have assets. The third part on which we have assets is about being scalable and elastic, of course. Once you have an algorithm that runs on one computer, it's fine, but suddenly you have a large number of users, you will need to be able to scale and duplicate the number of hosts running your algorithm. So our model I imagine is a platform where scientists are organized in teams that meant to be easy to use compared to existing solutions, and where there are clear guidelines on how you publish an algorithm so that it can be reused by others. Let's focus more now on image analytics and where we are right now. So we're about to launch the platform, and we decided to work with the CCTV market. And in London, there is 43 billion images that are looking to be processed every day. There is 5 100,000 cameras in London, CCTV cameras in London, which are recorded continuously, but most of the time people don't do anything with this image. And it raises questions about the efficiency of the systems that are in place. There's also two types of CCTV system, at least, that I would differentiate. Large systems that are the scale of a whole venue, that are where there are big computers inside of the venue that manage it, and small individual cameras that need to make meaning of the image that they face without having any resource, without having any big computing resource available. And these small cameras now, they're all moving toward video security as a service, meaning that they all upload the images on the cloud. And the next thing that comes naturally to all this video security service as a service provider is to think, okay, now I've got these images, what can I do? What are the services that I can provide to my users that have put a CCTV camera there? And of course, what they like to know if anything unusual happens, they like to be aware of it before rather than after and having to look in the log. They like to prevent bad things to happen rather than to have to wait for them to happen to use their CCTV footage. So, so it means that there is a need for interpreting this video. The problem is that so far, the systems that are in place, most of the time, you receive an alert because the cat has gone in front of the CCTV camera, or because the foliage has moved, or because your neighbors have turned the light on, and absolutely not because there is a real problem on the image. So people tend to receive too much alerts, and they say, okay, I'm not interested in that, and the alert systems that are in place right now are not powerful enough. And we clearly are in discussion with one of these CCTV providers that told us, okay, we're interested in working with you to find out if we can create a solution on the cloud to filter which scenes are normal and which scenes are not normal. So they like to process all these images real time, if possible faster than real time, with no GPU support. And what they like to understand is whether an event is a usual event or whether it's an unusual event. And to be honest, actually, they have two parts because there is also the camera, and so it's cloud plus embedded. And they're thinking of, obviously, as much as they can, I'd like to put something in the embedded part, but at the same time, we'd like for high-level analytics to get also a part on the cloud. So it ended up being probably some kind of computer vision pipeline that's going to say, okay, I'm going to do a background subscription, and I'm going to do a morphology, blob detection, and tracking, and whatever. What's interesting is there is that obviously one part that's going to go, when you create your models, there's one part that's going to go on the cloud, and one part that's going to be on the camera. And if you think at it from our point of view, seeing that there is actually a collection of algorithms that if you think as a computer vision researcher, not necessarily interested in every of these single algorithm, you might be, but they actually, for each of these algorithms, there's potentially a competition that exists there. There's potentially a quest for the best algorithm. And we go back to that initial question of the paradigm of software that are evolving more and more often. We see that there's obviously a need for a platform that would, there's, in my opinion, a need for a platform that would help innovation to be transferred from the lab towards different cases. And the way it's going to be deployed is also complex. It's also something where there is need for research and creativity. Especially if you had the constraint that some of the algorithm will imply machine learning, which means that there is a need for resources that have to be shared. It's not about simply parallelizing it if there is machine learning. If you think at a pipeline with machine learning, well, this is a naive pipeline with machine learning, but most of the time you will see that the code here is duplicated or multiplied by 3 in programmer's code because actually they want first to do their training program and then to do their testing program. And it comes with lots of questions on what is good software engineering and how we can do that nicely on the cloud. Or if we look for example, an algorithm that works on small elements, to be efficient an algorithm in the real world needs to be optimized according to the number of elements that he has to treat, whether they're going to be batch requests or single requests on the query. And that's obviously things that, again, need to be arranged in the platform. Which leads to the question on how we're going to price algorithm, and that's going to be related to metadata and meta-algorithm. And that's where I come back to what I mentioned initially on the types. On our platform, we have a system that I won't disclose right now because it's a public talk, and it's not launched right now publicly. But we have a system that allows anyone to attach information to images and to any data that's going to be processed. And I think that sounds very interesting, and around which there can be much more to be done to try to find out if we have that large amount of images to process every day. How are we going to be greener? How are we going to use less resources on making this platform a global point of sharing? How will we make this optimal for everyone, and rather than naive in terms of processing on the cloud? So the next thing the last thing I wanted to talk about was what we can offer now and what we expect to see, who we expect to meet. What we can offer now is we can invite you to be some of the first users of the platform. We can offer you some time to help you to start using the platform and put some algorithm on the platform. We obviously ready to let you use our cloud for free within reasonable limits. And we are very happy to invite you to our launch event that will happen in the second quarter of 2015, and to demo your work wherever we will go demo the platform. And what we look, of course, is people that have algorithms that are in video analytics that can interest the type of companies that we are going to meet. And so we look for people that works in CCTV analytics, and generally speaking, anyone that wants to make meaning of imaging, because I think there's, as I said, it's a question of team, it's a question of community. And we look for people that use the platform, obviously. We don't want people to just subscribe and not use the platform. So generally it means that we're interested in people that have the right talents to work with us or to supply elements on the platform, or whether they are algorithms or questions, whether they are directly elements of state-of-the-art that you want to share, whether you want to actually interrogate your peers through the platform. I think that's something that we are looking for, to create a dynamic on the platform. And the timeline, as I said, we're going to launch on the 15th of March. I don't know why it's made on the 19th here. But there's going to be a first registration on the 25th, where we're going to open the platform to those that have ideas about the problems that I mentioned before. And on the 5th of March, we're going to do a bigger pre-launch. 25th is the deadline for the registration, sorry, on the topic that I mentioned. 5th of March is the pre-launch of the platform. And the 19th is the date where we plan to demo the algorithm that have been uploaded on the topic that I mentioned. That's it, so thank you.